Hello students, welcome to Sources classes. Our today's topic will be integral transforms. So let us start with our first sum. Here is our first sum. It says find the Fourier sine transform of e to the power minus ax by x. So let us find the Fourier sine transform. So here we will write f p and in subscript we have s for sine equal to integration and limits are from 0 to infinity. The function will be e to the power minus ax by x multiplied with sine of sx dx. So let this equation be equal to I. Now we need to differentiate this whole equation. So differentiating differentiating with respect to s we get, okay, so differentiating I we get di by ds equal to differentiation of this equation will be d ds of integration over 0 to infinity e to the power minus ax by x into sine of sx dx. So integrating here we will get di by ds will be equal to integration over 0 to infinity e to the power minus ax by x into x of cos sx dx, which will further be equal to integration over 0 to infinity. Here we have e to the power minus ax into sx dx. So solving this here we get a by a square plus s square. So basically this is simple integration which brought us this a by a square plus s square. So now we can integrate this equation. So integrating with respect to s, here we get, so integrating this equation in left hand side we are left with I, which is equal to tan inverse s by a. Here in this equation we have 1 by 1 plus x square form. So here for that we have tan inverse x, so this will be tan inverse s by a plus c, that is constant. So initially we have s equal to 0 implies I equal to 0. So putting these values we get c equal to 0. So our final answer will be I equal to tan inverse s by a. So this is our Fourier sine transform of e to the power minus ax by x. So let's move on to our second question. So here is our second question. It says find the Fourier cosine transform of the function fx. So in the last question we had sine transform, here we have cosine transform, and the function given is fx equal to cos x if x is between 0 to a and 0 if x is greater than a. So let us start our solution here. So this will be fc of s, it will be equal to integration over 0 to a, our range will be from 0 to a, function fx multiplied with cos of sx dx. So solving this and putting the value of fx that is given here, which is cos x. So writing that we have from 0 to a cos x cos sx dx, sorry this is sx, and now we will multiply 2 in the integration. Here we have half outside and 2 cos x cos sx dx. So we have obtained here 2 cos a cos b form. So we have formula of 2 cos a cos b, that is cos a plus b plus cos a minus b. So applying that we get cos of 1 minus sx plus, okay, this will be x plus cos of 1 plus sx dx. So here we have two different equations. Now integrating this we get half of sine 1 minus sx divided by 1 minus s plus sine of 1 plus s into x divided by 1 plus s, and the limit says from 0 to a. So solving this further, we get 1 by 2. Here we have sine of 1 minus s into a by 1 minus s plus sine of 1 plus s into a by 1 plus s. So basically this is our answer to our question number 2. So let us move on to our third and final question. So here is our third question. Here it says find the Fourier sine and cosine transforms of 2e to the power minus 5x plus 5e to the power minus 2x. So first we need to find the sine, and secondly we need to find the cosine transforms. So let us first find sine transform, which will be fs of s, that is equal to integration over from 0 to infinity function fx into sine of sx dx. So it will be 2 into 0 to infinity e to the power minus 5x dx. Okay, so it will be sine of sx dx plus 5 integration 0 to infinity e to the power minus 2x sine sx dx. So solving this, I have only solved this previously to save the time of the video. So it will be 2s by s square plus 25 plus 5s by s square plus 4. So this is our sine transform of the given equation. Now we need to find the cosine transform. So let us find the cosine transform. So here is our FCS, which will be equal to integration over 0 to infinity f of x cos sx dx. So we need to put our equation there given in the question. So our equation is 2e to the power minus 5x plus 5e to the power minus 2x. So let us put it. So here we have 2 0 to infinity e to the power minus 5x and multiplied with cos of sx dx plus 5 in integration over 0 to infinity e to the power minus 2x cos of sx dx. So solving this, our final answer. So simply solving this integration, we get 10 by s square plus 25 plus we have 10 by s square plus 4. So our cosine transform of the given equation is this. So our both the sine and cosine transforms of the equation is formed.